Good. Welcome. Yes, that's me. Hi. We're happy. We're really excited to see so many faces join our talk. I'm really glad the clickbait title worked, and the cinema is almost full. So, my name is Manuel. This is Radhouan. We work at ProSiebenSat.1. We started working at the company a couple of years ago with the project that we want to share with you. I come from Colombia and I've been living in Germany for a while now, as well as my colleague here. We both have experience working in different industries, in different countries, and we found a place here in Germany and in ProSieben where we feel at home. So when we started working at ProSieben, one of the challenges that they were taking on was moving from a media company to a digital company. As you can imagine, this is a pretty big challenge for a TV channel. That's an industry. TV is an industry that's been stagnant technologically. They let competition come and sweep them off their feet. They had the content, but things like Netflix came, and they realized that they needed to change stuff. And one of the things that surprised me when I arrived at the company was that this process of TV programming starts 5 years in the future. So what we will see tomorrow started planning 5 years ago. If you compare that to other industries, for example, like auto manufacturing, the completion from a car from concept to hitting the streets is 7 years. So for me, it was really surprising to see that it's almost the same time frame for getting a car on the street to getting a program on your TV. Of course, this is different. The programming next week has most details. The programming in 5 years. It's a living process. It's a living thing. After every email, after every meeting, there's something that will change in this programming. Even stuff like world events changes this programming as well. Of course, for example, when the Queen passed away, what we had planned to show was no longer what we showed because the programming needing to be changed. And with many problems in our industry and in many other industries and in many other countries, everything starts with Excel. We've found, which was also surprising to me, that this scheduling process begins with an Excel sheet. Here you see a small example of one of those sheets. Here it's shown the different blocks, the different time frames. We call this a variant. It's just a name we internally have for them. It's a variant because you have one version, but there can be many of them. Each of those colored blocks represent one program. We call them slots. So for us, those programs, for example, for next week, have all the information you need that will appear on your guide. But those slots 5 years from now just have information like we want to show a movie. In 2 years, it could be we want to show a Marvel movie. In 1 week, it will be I want to show Captain America or stuff like that. In the TV programming, there are different blocks. There are different types of time that is differently used, and that translates for us in other sheets. For example, one block of programming, it's called prime time. Maybe you've people heard of this word. Another block is called daytime stripping, daytime weekend, or holiday. And everything translates from those blocks to one sheet in our Excel file. So you can probably see how big this problem is, how cumbersome opening this Excel file is. And to be fair, if I have to work with this thing every day, I will not really come to work really happy. But the problem, it gets a little bit bigger, because that is just for one channel. ProSieben has many channels. Here you see there are seven channels that we work with. You only see 6 because I like symmetry and I had like 6. So from one side, that's what people work with, this Excel file. From the other side is how people work with this Excel file, the process behind it. So a typical programming starts. Some of the people that work with this file come. They maybe create a new version. They open a new file. Maybe they copy a file from the year before, and they begin drawing those slots, assigning colors to those slots, and saying, OK, maybe in 3 years there will be a really maybe we will finally get a really cool DC movie, and they put it on the Excel, and they save that file to a network share. So there's one folder on the organization that has this file. Of course, it's not only one person that does this job. So maybe someone else comes and looks at the file. Maybe the first person said, hey, please take a look at my file. It's done. And the other one comes and says, oh, it's cool. I think we can make some changes to that file, so it's even better. And they create a new version of that file, and it's saved again in this network share. Maybe we have one version of this file that is shared, not from the network share, but is sent in an email to someone that has maybe some decision power in the company, but doesn't have access to the share or doesn't want to. And they say, OK, that's good, make these changes. Then one of the colleagues of this part of the company makes the changes and uploads a new version of that file. Or it can even happen that you have this file, this big Excel, you print it out, you take your ream of paper, you go to one of meetings with a lot of vice presidents that decide stuff, you show your planning, the people look at it, they see what it is, they make changes, and then someone has to upload it, again in this network file, in network share. The problem is what happens after that. We see there's a file there in the network share. How within the organization this file impacts something. We have another colleague that after each change, it's notified that there was a change. A phone call, an email, just a Teams message. They said, hey, we changed something, can you please update it? So this person has to go into this network share, look at the file each time a change is made, and then update it in another application from us, and where actually the programming is. So you can probably see, after thinking about how big are these files for so many people, that this process is a little bit cumbersome. It needs change, and that was the problem we wanted to solve. So we are around 300 users, just the people that have access to the file. Around 20 key users, those are the people that get to change the file. 5 developers, 2 of us are here. Another one is also with us today. We are two developers down. We're looking for people. We have one product owner and one Scrum Master. These are the initial tech stack that we used. There are some stuff here that we were able to choose. Some of the stuff here was already given by the company. For example, we chose Vue.js. None of us is a front-end developer, so we thought that the learning curve for Vue was easier for us to start. We also, but for example, using Azure for authentication and authorization was something that already was in the company. We had really a lot of freedom to choose our tech stack, and we're kind of good with this one. So, like many things in Agile project starts with a bunch of stickies. Our first approach was to meet with our users, do a design sprint. We spent 5 days together, working together, developing prototypes together, and at the end we came with a solution that seems to be working for us. After those 5 days, we came with a list of functional requirements and non-functional requirements that we want to tackle. For us, important is from the non-functional requirements is speed and usability, because the people that work with this Excel file, they are like monsters. They can change that style sheet like there's no tomorrow. You see them working and you're surprised that someone has those abilities with Excel. It's really astonishing. And from the functional requirements, we want to be able to create those plannings, those variants that I showed you. We want to be able to draw slots as freely as possible, and we want to be able to offer a way to collaborate. That way, there's no exchange of files, there's no sending of emails, there's no need to upload stuff on any network share. And of course, at the end, what we want to do is export that to that other application that really holds the truth. We did at the beginning one event storming session with our most important key users. From then we were able to get a model from the domains that we want to tackle. We started with one pretty basic architecture. We at one end we had our REST API, request response, and on the other side we had a database, pretty standard. But when we wanted to focus on the stuff that was within each domain, we went with a hexagonal architecture. We knew from the beginning that that type of architecture, that REST calls, was not the thing that we wanted to use in the future, but we wanted to move on with our domain. So having that gave us the ability to say, okay, we're going to postpone the decision what we're going to use to the future, not now. But we have some cons, of course. With every pro there comes a con. And there's a lot of boilerplate code, a lot of transformation that happens. For that we use Mapstruct that has solved maybe 95% of the problems that we had with that. And we are really happy that all of the testing that we have for our models remains the same, even if we change what is around. That's a little example of how hexagonal architecture looks like. This will not be a hexagonal architecture talk, sadly, because it's really interesting. We can talk about it if you guys want after the session. And we had, at the end, we had money to 1.0. We went a little bit to the past, thanks to Git, and we rescued some of the things we had at the time. We made a little video of how it worked. Here you see a little bit of how we envisioned that these variants were going to work. We have some of the attributes that each slot has, and that's really pretty specific. But one of the bigger problems that we had with this type of architecture that we showed was performance. So here we will create a new variant for one specific broadcasting time, and when we wanted to edit that, we created a small wizard that was able to put a slot, like a big slot, on the time. And when you configure it and give it a go, it looked like the application just hanged. And as a user, the backend is working hard. We're really doing stuff. But because it's request response, the user just clicked something, and it's waiting, and it's waiting, and it's waiting, and it's still waiting for something to happen. Of course, that goes completely against what we set up to do at the beginning. And if you try to say, OK, how fast are these persons with working with Excel, and you compare it with that, there's no comparison. We had the same problem also by deleting, but we knew stuff needed to change. So from our list of non-functional requirements, we were happy that we got the reliability and security ones from the beginning. Speed, usability, and performance needed a lot of work. And from the functional requirements, collaborative work and undo redo, that's stuff that we really wanted to provide to our users was, unfortunately, with the architecture that we had at the time, not really possible. So what we achieved, we did not achieve everything that we wanted for the beginning. But we were able to provide a way to create something like one of those variants and export it. At the end, this is the most important thing, to export it to the other side. And now I give it to Radhouan. He will take us into that was the past, and he will show now the present.
Thank you, Manuel. I mean, you mentioned if you work with the Excel every time, then you will not come to work. If I work with this state of the application, I would have quit the job because it's too damn slow. And yeah, all the operations are slow. Deleting is slow, creating is slow. Everything is done synchronously, so we are always waiting for something to happen in the backend and then update the front end. We have a lot of data in the front end, so to export them in the backend, to persist them, it takes a lot of time. And the performance, and we are relying too much on the backend. I mean, a lot of people told me at the beginning of my career, keep the front end as light as possible, do everything in the backend, it's better. In our case, it's not the case for us. We need to do things in the front end, and so we just did a little bit of retrospective. Reading the initial load is good. We are getting the initial load, we are getting the variant, and we are getting the data to work with. The problem is when we are trying to altering this data, to change it, to update it, to delete it, and so on. And so it was clear for us, reading process and writing process is different. So that led us to an architectural pattern which is called CQRS. And it's actually just about separating the read and the write, separating the way we are altering data and the way we are retrieving data. So CQRS is architectural pattern. It stands for command query responsibility, segregation, and it's about segregating. So it has two things to concept. It's command and query. Command, it's an instruction to perform some task, and query is just retrieving some data. In the picture there is like a database for writing and the database for reading. So they are separating the read database and the write database, but we didn't do it because it's not something we want to do, and we don't need it actually. And that has a lot of benefits as well. It's clear boundary between the different system behavior, because they have the read behavior itself is in one place and the write behavior is another place. That gives us also a bit of we are close to the business logic, because all the business use cases for writing is on one place and the other are in another place, and it leads maybe to better code, because separating will maybe reduce the chance of ending with spaghetti code and everything is the same and in the same place. We'll try to show you how we implemented this architectural pattern. So for the reads, as I told you, we didn't change anything. The read is working fine, and we are using HTTP REST, and we are getting with all the gets we have. And we have our Hexa architecture in the backend, and We are using this port to get information, and that's all. What we changed is the backend. We are using now, what we changed is the command, the writing process. And we introduced a proxy there, and we are using something called command, which is like command use case. And the command actually is a list of actions. An action has an action context. The context, we need the channel ID because we are subscribing to this channel ID. I don't need to change something in another context for another channel. And we need the client ID, so we can know which client sent this information, sent the command with these actions. And we have an enumeration with multiple actions, like some create variant action, delete variant action, create slot action, and a lot of actions there. We'll go to there. I'm a bit lost. Yep. Yeah, this is the architecture. We told you we need it from the beginning. We didn't know if we are going from the beginning with the right architecture. So we try to make a ready to change architecture. And that's what hexagonal architecture is for. So we had this port, the channel use case, which is the in port, and we were doing all the create and delete and update operations through this use case. The use case has, like, I don't know, create slot, update slot, and delete slot. And instead of doing it now with the REST adapter, with controller, REST controller and everything, we are doing it now with commands. So we didn't change any of our business logic. We are just changed the adapter. We are not using the REST adapter anymore for writing. We are using command adapter. And this is the whole architecture, how it looks. I forgot something necessary. It's Kafka. Yeah. We needed to write command in some place. We started with an in-memory queue, and then yeah, we switched to Kafka, and we have some topics, and we write the command in these topics, and yeah, some other component at some place will just yeah, get the command and process it in the back in the services. So what we achieved, yeah, we are now communicating asynchronously with the backend. We are no more waiting for the backend to update our display in the front end. We are saving the state in the front end, so the front end can work independently from the backend. And we need just to have faith in our backend that he does everything right and that we don't get anything from that. Okay, the live demo. Let me see if I can do it and if our VPN is working right. I hope. I'm not getting it. It's a problem. Ah, nice. But I'm not seeing it here, so I need to go. Yes. Yeah. We prepared something here. And this is the initial load we talked about. This is the get at the beginning. And the difference to what Manuel showed you at the beginning, where I create a slot for a movie or something, and I need to wait like 5 or 6 seconds, sometimes for a big slot, like 15 seconds. We do it now directly. But it's there. We don't need to do anything. We can change the name, change the color, put it like a fictional movie. It's so big. And it's always there. I can move it as well, and it's instantly there. So the performance issue we were having when talking just synchronously with the backend, we don't have it anymore. And if we go a bit here and see the network, what's in the network there? So to every interaction I do, there is a command here. Well, it's not sure. Yeah, you need to take my word for it. There is a command with action there, and yeah, for every interaction I'm doing, there is a command sent to the backend. It lands in the proxy, and at the end will be written in the Kafka topic, and it will be consumed from one of our services. Okay, so I need to go back now to, if I can do it. Technical issues. I hate Mac. No. No, I don't. I'm just kidding. Okay. Okay. It's really, it makes me sorry for that. It doesn't want to. Yeah, I need to trick it, so. It's really bad. No, I don't think. Can you? The technical guy is coming, so.
I'm just a pretty face.
Thank you. I'm bad with technique. I'm just welcome. So the retrospective. Actually, we've done a lot of good things, but I told you we need to have faith on our backend. So no errors happens in the backend, and of course we talked about at the beginning to have a collaborative interface, so multiple users are working on the same variant, but there is no way in this kind of architecture to get the update from other persons. So we needed to make it a bit reactive. We needed to get information from other systems and so on. So we were using polling, and the discussion was about, how many seconds do we need to get data from the backend? I'm kidding, we didn't do polling, we did RSocket. And it's just coincidence that we are just taking things from Netflix. Everything that Netflix is using, you are using it here. It's just coincidence. What's RSocket? RSocket is a binary protocol for use on byte stream transport. And we live in reactive streams era, so that's pretty much good for us for our use case, because it provides a protocol for reactive streams. It has a built-in support for reconnection. So if the connections between the client and the server is lost, we get the reconnection automatically. It's used for communication client server, and as well server, because some other framework, I would say, they just offer server communications and not client server. RSocket offers both of them, so that's give us also an opportunity to completely maybe replaced all our REST endpoints with and have consistency, so we do everything with RSocket in the future. RSockets offer a request response, what Manuel talked about, and what we are doing in getting the information. It also uses fire and forget, so we cannot send something and don't wait for it. And it offers stream, so I open a stream and I get all the updates, and that's the use case we want from our backend, because I'm subscribing to some channel, I'm getting every update to this channel. So this is the architecture CQRS without the RSocket, and this is with the RSocket. So what we introduce here are three things. We introduced a new topic, an event topic, and we introduced a command handler, which is the Kafka producer, who will produce this event to the event topic. And we introduce as well the client notifier. The client notifier, every client, every browser, when it opens, it will subscribe to the event client, to the client notifier with a channel ID, with a specific channel ID. So it gets all the updates for this particular channel. As I showed you, a command is a list of action, but an event here is just one action and an event type. Event type, it can be an error, so we know we have an error in the backend, and we inform the front end, so he will refresh the page or anything. And there is a normal event coming from another client, so someone created a slot in this range of time and this range of calendar week, and he will get it as well. And this is the whole architecture, the CQRS plus the RSockets. So let's do a use case together. I mean, there is client user one who starts a client, and yeah, the front end or the client will create a command. The command will be sent to this proxy. It will be processed and validated and everything. And then at the end, it will be written in the planning topic, for example, in this use case, when, let's say, the action itself is create slot action. So it lands in this planning topic. We have a command receiver in the planning service Hexagonal. It's listening over the planning topic and will retrieve the command and actually will process it in our business logic, and the command handler, this one, the command handler will wait until the action is done and is done correctly and there is no errors or something, and then he will emit an event in the event topic. And when there is an event, every client who is subscribed to the client notifier for this particular channel, he will get at the end the event. And of course, the front end will update its state. And these new slots will also pop up in his, we call it schedule, so in this grid. Good. Yeah, this is the front-end architecture. We are talking about this, we call it return channel. So it's like when something happens within another client, all the client interested in this event will get updated. So I will keep showing the front-end part of it. So as I told you, this is a client, and the client will subscribe at first to the client notifier. So now an event comes, and it will be given to the return channel component. It will be like processed, transformed to something which known by the front end itself, so front end actions. And we have here something like central, which is an event bus. And the event will just be written in this event bus. And like in backend, we have the same. I mean, we try to do it like event-driven architecture as well in the front end. So we have an event bus, and there comes a lot of events. And every component, view component, and is listening to this event and subscribe to specific actions. So when an action comes in the event bus, the view component who is interested in this action will just take it, transform it, commit the new state in the Vuex state. Vuex state, for the one of you who doesn't know, is something like Redux in React, or like state management tool in Vue. And when, of course, the state is committed in Vuex, every component which using this state will update the state, and yeah, we'll get it. And now comes the live demo. I had it. Technical guy, can you do it? Yep. So I showed you that time that I'm doing something and it's get done really fast and it's performant. And now we have an imposter in the audience. It's like one of our colleagues, but we bribed him to ask us afterward easy questions. But he will help me now to show this return channel. I'm not doing anything. I'm really not doing anything, and he will be doing the job. So we are both working in this variant, and I'm seeing live actions. Can you do some magic, Marcus? Like change things, delete things, update new things. Yep. So we are both subscribed to this variant, and we are both working on it collaboratively. And what he's doing, I'm getting it real time. And this way, we offered our users to work simultaneously, to just not have one Excel and the other Excel, and they work separately, and then they meet and they try to say, what are the slots we did the same, what are our differences, and so on. So this is also an added value for us for the project. Thank you, Imposter. Yeah, something else, another requirement. Is it done? I need another 5 minutes, it's cool. Yeah, what we needed as well is another requirement, because they are working and they are like drawing things, and they need to undo these things. They need to go back in like steps before and change things. And we couldn't, I mean, we have imagined, we tried to have like meetings and discuss how can we do this redo and undo functionality using the traditional architecture what we had at the beginning. We didn't have any answer for that. But with events, we can just create an event and the opposite of this event, and then like play with them, with both of them. So I will try to demonstrate the undo redo case. I have a new slot created in some planning component. I mean, I draw a slot. So the slot will be created. It will be sent to the planning service. The planning service will wrap it around the command. Will send the command to the backend. And at the same time, it will create an undo and redo action. The undo action is the contrary for this particular action sent to the backend, and the other one is just the same. And it will send them to the undo redo component or service, and the service has just two lists based in LIFO, last in, first out, and it just push them in this list. So if I am yeah, I go and I click the arrow back, and so I trigger the undo. The undo redo component will just fetch the last action from the list, and it will just push it as well in the event bus. It's the same as the return channel. So both of them are using the event bus, and everything comes with the event bus. So it's like central there, and from there every component is listening to some action and is doing it. Yep. Live demo again. I'm sorry, Manuel. Actually, I need to do it. It's cool. I think the talk should be fun as well, so it's not just talking. And you saw a lot of diagrams. We develop a lot of diagrams, so. Yep. So I will try to create something here, like a little bit, and then some other thing. And we have the two arrows here, if I'm seeing it well. So if I click there, it will go. And yeah, we have, I'm not seeing it. I don't know, where is the other arrow? I don't see it. But we can like switch from undo and redo all the time. You should have learned it by now. You are embarrassing me, so yeah. I'm concentrating on presenting. Yeah. Yeah, so this was our API at the beginning, and you see a lot of CRUD operations there. And this is our API now. We are just posting command and all the other gets. It is, yeah, we have like introduced RSocket and Kafka as new technologies. And for the requirement, we are having like, yeah, we, in our mind, we did all the NFS and we did all the functional requirements as well. What we achieved now, we are communicating asynchronously, the performance is good, the time as well spent, and it's fun to work with our product now, and no one will quit because of our product, so that's a good thing. And yeah, all the interaction as well can be redone and can be undone, and we can at the end export all the information built in our software to other systems to get finally in the in the TV. What we still not, because as the title Manuel told you, it was like fishing. The title is the perfect tool. Perfect for us means ongoing, try to make it better, and architecture should be always reviewed and should be made better. We have some ideas there how we can make it even better as it is now. So maybe at some point move away from monolith microservice to a real microservice architecture if needed, and use RSockets for every other type of communication. Maybe we are doing a lot of calculation as well and transformation in our front end. Maybe do this static transformation and calculation in some lightweight service in the backend, because it has more resources and can maybe calculate things better. And also migrate to Vue 3, because we did the mistake of using a library Vuetify, and it has not yet updated to Vue 3, and that's why we are stuck with Vue 2 until now. Yep. Thank you for attending our our presentation. We tried to make it fun as well, and I hope you gave us questions, you gave us suggestions and command, and maybe you have some other ideas. You have experience doing the same with another concept, so share with us your experience and everything. And as Manuel said, we just lost 2 good developers, and we need some more developers. If you want to share our passions for our tool and for our ProSieben, you can join us and work with us. Thank you.